Now, the scale of atmospheric motion. We have different types of atmospheric scale: microscale, mesoscale, synoptic scale, and global scale. We'll be talking each of them now. So, the scale of the atmospheric motion, the tiny microscale motion constitute a part of the large mesoscale motion, which in turns are the part of much larger synoptic scale. So if you look at the scale become larger, motion observed at a smaller scale are no longer visible. So the scale of the atmospheric motion with the phenomena, average size and lifespan, you see in the middle of this picture, because the actual size of the certain feature are different. Some of the feature fall into more than one category. So considering first, the smoke rising from a chimney into the otherwise clean air in an industrial section of the large city. Within the smoke is small chaotic motion. We can see tiny eddies, and those are causing it to tumble and turn. This eddies constitutes the smallest scale of the atmospheric motion, and this smallest scale of the atmospheric motion we call it microscale. At the microscale level, the eddies with the diameter of a few meters or less than only disperse smoke, but they also have the fly away branches and dust and papers into the air. They form by convection or by wind blowing past obstruction and are usually short-lived and lasting those types of scale lasting for few minutes at best. As we know that the smoke rises, it drifts toward the center of the town. So the smoke rises even higher and carried many kilometers downward. So these types of bigger circulation than the microscale circulation, we call it mesoscale, meaning the middle scale. Typically, mesoscale circulation range from a few kilometers to about 100 kilometers in diameter. Generally, they last longer than the microscale motion. More often, many minutes, sometimes hours, or in some cases, a day. So mesoscale circulation include local wind, which form along the shoreline and mountain we see a lot, and also we see thunderstorm, tornado, and small scale tropical storm or tropical cyclone are fall into this mesoscale. Sometime we look the smoke shake on the surface weather map. So we see that circulation around high and low pressure areas, the cyclone and anticyclone of the mid latitude, and we also see the large tropical cyclone of the lower latitude. We are now looking at the synoptic scale that is bigger than the mesoscale. On a weather map scale, circulation of this magnitude dominates regions of hundreds to even thousands of square kilometers. Although the lifespan of these features are different, they typically last for days, sometimes for weeks. These include large hurricane and typhoon as well as frequent mid-latitude storm system that brings a lot of precipitation, snow and wind. Lastly, the large wind pattern are seen at the global scale, or we can say planetary scale. So here we have wind pattern ranging over entire Earth. So this global scale we have Hadley cell, Ferrel cell and polar cell. We have northwest trade wind, southwest trade wind. All are derivative from the pressure belt. So together the synoptic scale and global scale are referred to the macro scale, the large scale of the atmospheric motion. So if we can summarize about different types of scale, we can say the small turbulence AD cause the microscale, and thunderstorm, tornado, water spout, dust devil are also macroscale, and hurricane, tropical storm, high pressure, low pressure system, and different types of depression, tropical depression, or fall into um, synoptic scale, and global scale pattern. Those are big scale which around the planetary scale that are Hadley cells, northeast wind, southwest wind, and different types of derivative from pressure belt are known as global scale.